Today we'll see about another part of semantic parsing. So we are in the chapter of semantic parsing. So what we do in semantic parsing, we take the syntax tree tree from the syntax parsing, and we have discussed that there are two types of trees. One is a phrase structure tree, which is also known as constituent parsing tree. Another is dependency parsing tree, where we have head word and the dependent words are modifiers. Now the question is, do we need to use the whole large tree, or even if we use a part of that, is it sufficient? The concept that we are coming at now is very similar to the ensemble learning. In the previous class of machine learning, we talked about ensemble learning. In ensemble learning, uh, we instead of using a big, large decision tree, we used small, incomplete trees. And there we discussed about bagging, boosting, random forest, this thing. What is the concept there? You have a big decision tree, but the problem with decision tree is overfitting. Instead of using big decision tree, we can use small incomplete trees. The same thing we are doing here when we talk about chunk representation. Instead of using the whole syntax tree for as input to the semantic parsing, what we can use is we can chunk it, we can cut it, and we can use a part of that. So chunk representation, it involves breaking a sentence into smaller flat group of words called chunks or base phrases. So in full syntax tree, we will have all the relations and which one is head word, which one is dependent word, all those relations. But here we don't include chunk representation is not bothered about the relations or structure. It is only about the parts. So focuses only small phrase units like noun phrase, verb phrase, prepositional phrase, and so on and so forth. So the chunk parser or chunk representation, they are not bothered about how these chunks are connected to each other, but they are bothered only about the chunks. So in chunk representation, sentence is divided into non-overlapping units called chunks, and every chunk typically corresponds to a base phrase such as noun phrase, verb phrase, prepositional phrase, something like that. So this approach is commonly used when we want to identify the arguments without deeply analyzing the syntactic relations among them. And in chunk-based systems, often we use an approach called IOB representation. I inside the chunk, B beginning of the chunk, and O outside, which do not belong to any chunk. So this method is very effective where segmentation into phrases is required. For example, John gave Mary a book. So John is tagged as B and P beginning noun phrase, gave beginning verb phrase, a book beginning noun phrase, and inside noun phrase, Mary as beginning to Mary as beginning propositional phrase as well as beginning noun phrase. So when we are using chunk representation, our goal is not to capture deep hierarchical relation between the words, but we want only the meaningful phrases in the sentence. So the simplicity of chunk representation makes it robust in case of where syntactic structure might be ambiguous or incomplete. So, for example, if we take a sentence, sales declined 3% to five the $524.5 million from $539.4 million. A full syntax tree. What will it will cover everything? What is the subject? What is the object? What are the nested phrase? Complete grammatical relations and everything. How they are connected with each other. But whereas chunk representation, it will is not bothered about how they are connected. Just what are the different parts. We are not bothered about connection. So noun phrase sales, verb declined verb phrase, 3% noun phrase, two propositional, like this. So advantages are it is fast to we can easily generate it. We can generate them fastly. It is robust. It can work with noisy text or speech, and for it is used for many tasks. Particularly, it is effective for semantic role labeling. They are computationally efficient and well suited for processing large volumes of text, and they are very much effective for semantic parsing or semantic role labeling, where precise syntactic relations are not much important. But there are certain limitations because we are not capturing the syntactic relation that will hamper the semantic role labeling where full syntactic tree is used. Obviously, when we use full tree, the performance will be higher. But here we are taking a chance, we are taking a trade-off. Instead of using full tree, we are using chunks. But it is more robust and it is more simpler. So because we are taking only parts, that may result in loss of information. And for complex sentences where the relationships are important, we are at the end of, we are at the loss. So this approach may not perform well when deeper syntactic or semantic relations are important. So generally these chunk parsers, they will be using SVM classifier. Gildy and Palmer, they worked on this uh, chunk parsing, chunk based parsing, and they found that the performance is less when we use full syntactic parsing. Instead of full syntactic parsing, if we use chunk based parsing, the performance is obviously low, but they proposed that we can improve the performance of the SVM. So when we use SVM for semantic role labeling with chunk based parsing, so there are two stages in this parsing. One is chunking stage, where we break the sentence into flat chunks, each labeled with a syntactic tag, noun phrase, verb phrase. The second stage, the semantic labels are assigned to this. What is argument 1, what is argument 2, something like in prop bag. So these are the features used for semantic role labeling: words, predicate, lemma, parts of speech tags, position of the base phrase using BNP, INP, O, IOB, clause tags, named entities, token position, before, after, path, flat path between the token and the predicate, clause position, head word suffixes, length, number of words in a token, predicate, POS tag, predicate frequency, predicate BP const, base phrase context, predicate parts of speech context, different surrounding words immediately preceding or following the predicate, predicate argument frames, and the number of predicate. These are the different features. By using these features, uh, they got F score about 70. So it is used for argument identification as well as argument classification.